For this problem, we're going to again find the domain of a function and then evaluate the function at a given value. We want to find the domain of the function h of x equals x minus 4 divided by x squared plus 5x minus 36. The only thing we need to worry about here is this denominator because we cannot divide by 0. So we want to find out where the denominator equals 0. So we'll start by setting the denominator equal to 0 and solving this equation. We have a quadratic equation that we can try to solve by factoring, and this does factor as x plus 9 times x minus 4. So this will give me x equals negative 9 or x equals 4 if I set each of these factors equal to 0. So we've got these two restricted values. If we rewrite our function in factored form, we'll have x minus 4 over x plus 9 times x minus 4. Now notice that we have an x minus 4 in the numerator and an x minus 4 in the denominator. You might be tempted to cancel the x minus 4 factors. If we did that, we'd end up with 1 over x plus 9. But then our domain is different because here we can actually use 4 in our function, but up here in this factored form we cannot. So we still need our restrictions that x is not equal to negative 9 and x is not equal to 4, and then those two would be equivalent. So our domain is the set of all real numbers for x such that x is not equal to negative 9 and x is not equal to 4. We need to exclude both of those values even though we can reduce this eventually. Next we want to evaluate the function at negative 1. So we want h of negative 1. That's equal to negative 1 minus 4 over negative 1 plus 9 using the factored form, and negative 1 minus 4. In the numerator we'll get negative 5. The denominator will have 8 times negative 5. Notice the negative 5s will cancel. It comes from that common factor. And so we end up with 1/8. And you could have evaluated the function at negative 1 using the original form, and you would obtain the same answer.